All right. Hi, everybody. There was an email to me and a post on the Talk to Me forum regarding problems in chapter 2 in the book and on quiz number 1. So I'm going to go over those right now very quickly. 1 second. Okay. So the first one that was asked was about problem 12 in the book. And so this is actually a really good one for understanding how pKa is related to pH and the ratio of conjugate base to acid. So it's problem number 12, and it says acid-base chemistry. Using the Henderson-Hasselbalch equation, show that for a weak acid, this is a very important sentence. The pKa is the pH at which the concentration of the acid equals the concentration of the conjugate base. So if you can understand this about the pKa, that's really, really important. So the pKa is the pH at which the conjugate base equals the acid. The concentration of those are the same. So how can we use the Henderson-Hasselbalch equation to determine this? There's actually two different ways. So with the Henderson-Hasselbalch equation, so it's pH equals pKa, sorry, I just had a lot of coffee, my hand is shaking, plus log base 10 of the conjugate base over the acid. So if let's plug this equation in where basically the conjugate base and the acid are the same concentration. So let's say the base A minus equals 0.5 molar, and the acid also equals 0.5 molar. So that would be 0.5 over 0.5. You can do this for any equation. Let's say this one is 0.01 and this one's 0.01, or they're just like 2 molar over 2 molar. It doesn't matter. Just as long as the concentration of both of them are equal, then this ratio of the conjugate base to the acid is going to equal 1. So what does that mean for our equation? Well, the log of 1 equals 0. So then you can just take that out of the equation, and the pH is going to equal the pKa. Okay? So play around with that. It's pretty simple, but if you can understand that, it's really, really helpful. The other thing you can do is just make up a value for the pH and the pKa. So again, pH equals pKa plus the log of conjugate base over the acid. So let's just make the pH 6 equals the pKa is 6 plus the log of A minus over HA, log base 10. So if you just subtract 6 from either side, you get 0 equals the log base 10 of the conjugate base over the acid. So if you find the anti-log of that, just using this trick, that's 10 to the 0, which equals 1. So this would be 1 equals the ratio of the conjugate base over the acid. So make sure you play around with that a little bit. It's really important to understand that the pKa is the pH when the conjugate base and the acid are equal. If you go below that pH, that means that the acid, the protonated form, HA, is going to be the dominant form. If the pH is above the pKa, then the base, the conjugate base, the deprotonated form, A minus, is going to be dominant in that solution. Okay, the next question that someone had that someone asked me about is actually not one that I recommended because it has to do with finding Ka. I don't need you to be able to find Ka for this course. I go over it a little bit in the lecture, but it's not something I'm going to ask you on the exam. But I can go quickly through this problem anyway. So warts beware. So the pKa of acetic acid is 4.6, and the pKa of trichloroacetic acid which is used to remove warts, is 0.7. So it's a much lower pKa. So calculate the dissociation constant, which is Ka of each acid. So which is the stronger acid? Now, in my lecture, I go through this a little bit when I derive the Henderson-Hasselbalch equation, but basically the answer to this question comes from the fact that pKa equals the log of 1 over the Ka. So we can find that out. So we already know the pKa. So the pKa of acetic acid, so acetic acid, pKa equals 4.76. So if we find the log of 4.76, so the pKa, well, no, that's not right. But if we find the anti-log of that, that would equal 10 to the 4.76, which equals, plug this into my calculator, log of 4.76. Oh, no, sorry, 10 to the power of where is that on my calculator? Oh, sorry. So 10 to the power of 4.76 equals 5,543. Okay. So so if we go back to this equation here, we can see pKa is just the inverse of that value. So actually, we've just found the 1 over Ka. So this would equal, so the Ka is going to equal 1 over 5,543. 1 over 57543, which equals 1.73 times 10 to the negative 5. So that's the dissociation constant of acetic acid. So trichloroacetic acid is 0.7. So we can find the anti-log of that very easily. That's just 10 to the 0.7, which equals, so 10 to the 0.7. Oops. So that equals 5. That equals 5. So basically, so then 1 over 5 equals the Ka, which equals about 0.2, if I did that correctly. But again, you do not need to find Ka for this course. Okay, this is a general biochemistry course. This is something that's more important for general chemistry, basically. So that's why I didn't recommend this problem. And so you're not responsible for this information, but that's how you would figure out that answer. So it is useful to sort of know that equation right there. Okay, the other one that a few people were having trouble with was question 7 on the quiz. Now, to make everything fair for each other, I'm not just going to give you the answer to that. So I just changed one of the values in this. This is slightly different than in the quiz. So don't plug in the answer that I'm about to figure out as the answer on the quiz. You will get it wrong. So this one is saying that a lactic acid buffer at pH 5.86, that's the value I changed. So you can just plug in the different values. Contains 500 millimolar of sodium lactate. So of course, sodium lactate, that is A minus. So that's the conjugate base. Lactic acid is HA. So what's the concentration of lactic acid present in the solution, given that the pKa of lactic acid is 3.86? So for this one, you just need to know how to use the Henderson-Hasselbalch equation. pH equals pKa plus log base 10 of the conjugate base, lactate, over the acid, lactic acid. So we know the pH in this problem is 5.86, and the pKa is 3.86. So I made these nice round numbers. We also know the concentration, so plus log base 10 of the conjugate base, so that's 500 millimolar over HA. HA is what the concentration of HA is what we're trying to find. So we can subtract 3.86 minus 3.86. So 2 equals log base 10 over, let's just go back to A minus over HA. So we'll find the anti-log of that. So 10 to the 2 equals the ratio of A minus over HA. So that's 100. So there's going to be 100 times more A minus over HA. So that's 500 millimolar over HA. So you can do that. Rearranging that, it gives us HA equals 500 divided by 100. So that equals 5 millimolar. So that's how you do that problem. If that's still unclear, please let me know and I'll try to explain it in a better way. So don't put in 5. So this is not the answer. Not the answer for question 7. But it's very similar. You can figure out the answer using the same way. So if you have any other questions on any of the problems, please let me know. Do note that on question 1, there's multiple answers. It says 4. I should have put select all that apply, but there's 4 main biomolecules in biochemistry. Proteins, nucleic acids, carbohydrates, and lipids. So all the other ones that aren't just listed as that are going to be the ones that are not considered the 4 main classes of biomolecules. Some of them may be within those classes of biomolecules, but they're not the title of the main class. But yeah, again, if anybody has any more questions or wants to discuss anything over Zoom today before you submit that quiz, please let me know and just make sure that you get that quiz submitted by at the end of the day, Central Time today. So thank you very much. Let me know if you have any questions.